Hey, we are Group 17. Today we would like to demonstrate our proper proposal, which is a claw machine. First, let's start with the functionalities of this machine. We start the gameplay by inserting HK coins into the coin acceptor. The coin acceptor recognizes the type of coin and display the total balance on the LCD and touch the start button on screen to start the game. Players can use joystick to control the movement of the claw and press the button to drop the claw to grab the prize in the machines in his desirable position. And a 120-second countdown timer is set to stop the game automatically, and the claw will go back to the original position automatically. If the player successfully get a prize, a special music will be played. Let's start to introduce the components of this machine. First is the coin acceptor. It is a 10 kg load cell with a HX711, which is an ADC module to give out the serial output. It can be accurate to 1.2 mg with a 10 kg load cell. It is sensitive enough to distinguish the 4 times of Hong Kong dollars. The next part is the joystick and button. We use it to control the 4-direction movement and trigger the claw. And we use the Semver 5P version, which is just simple GPIO. The next part is the LCD. It is used to display the balance, $1 per gameplay, and display the running time. As we mentioned before, there will be a countdown timer. And we will have a very simple touchscreen user face. And we use the model as what we used in the lab. The next part is the most important part, the XY stage, which is all the movement of the claw will be on here. And it's comprised of a GT2 pulley and a GT2 belt. We will use 42 stepper motors to control it. And the torque is about 0.45 Newton meter, which is large enough to drive the system. And we use this stepper motor because it is very stable and it can drive friction load and inertial loads. The next part is the claw, which we will design a pulley system controlled by stepper motor to pull up or drop the claw to grab something. And the claw will be controlled by a servo motor because of the precision of the open angle.
Hi everyone, my name is Gil. So finally, we have a background music generator. We will use ATK VS1053MPV, which use SPI communication protocol. And then we use this because it's convenient to use. It has a module interface and the functions provider, which also it has good sound quality. And for the role of the microcontroller, it's basically a program which first does polling to check the state of the coin acceptor. And then it uses LCD, joystick, button, and music to create the game environments for the players. And third, it provides PWM to the motors to control the motion of the motors. And fourth, it sets up a countdown timer and generates an interrupt to terminate the game. So we provide an implementation pseudocode, and I will walk through it. So first, it has an update balance function to read and update the balance from the coin acceptor. And then if the player presses the start button on the LCD, we will check whether if he has enough money. If he has, we will block the coin acceptor, start the timer, and then start the game. Otherwise, we output an error message. And for the game logic, the claw machine will first play the background music, and we have our route to repeatedly check if the timer has expired. And the player can use the joystick to control the direction of the claw. For example, move left, move right. And if the player presses the drop button, we will stop the timer, drop the claw, and then grab, and then return to home position and then release. For the timer interrupts, we will have an interrupt service routine to periodically update the screen. And when the timer reaches 0, the claw will just drop and then grab and then return home position and release. For other functions, we have functions like coordinate and control the motor XY stage, correctly time and control the actions of the claw, communicating with the touch screen and displaying on the LCD, communicating with the coin acceptor, and finally playing music. And that's it.